Myself D.Thirupathi. I am Assistant Professor in ECE Department in Vaageswari College. Today I am going to discuss about basic signals. First of all, talking about what are types of signals. So before going to basic signals, we talk about what is my continuous time signal, what is my discrete time signal. So before we are going to continuous time signal, discrete time signal, first of all we talk about signal. So what is the definition of signal? Signal is nothing but carry the information. So carry the information is nothing but if you take any signal, signal has some information. That is called, that's why we are getting some name that is called signal is nothing but carry the information. So what type of information is the signal is carrying any type of information. For example, traffic signal, voice signals, and sound signals, and etc. So we take any signals we have some carries information. For example, we take traffic signal. For example, what is the traffic signal? Traffic signal gives us some information. For example, I want to move the one road to other side. The traffic signal gives us some indication that is called red light. Red light indication nothing but that is we have to move. So move nothing but you have to we have considered nothing but it is called a signal. Generally, another example, voice signal. Voice signal also gives some information like example, that is also one of the voice signal. Now coming to signal is majorly two types. Nothing but continuous time signal, and discrete time signal. So in the signals we have represented two ways. First one is continuous time signal and second one discrete time signal. So now coming to the definition of continuous time signal, the continuous time signal favor the signal is continuously varying with time, that is called continuous time signal. That is the definition of continuous time signal. So continuous is nothing but the signal is continuously varying with time, that is called continuous time signal. It is denoted by the x of t. So t is nothing but continuous variable. This definition is called continuous time signal. Now coming to definition of discrete time signal. So discrete time signal is nothing but every amplitude depends on a particular instant of time. That is called discrete time signal. It is denoted by the x of n. X of n is the amplitude. This is nothing but is all the time period. So the every amplitude depends on the particular instant of time. That is called discrete time signal. Also, this is the definition of continuous time signal and discrete time signal. These are major two types, continuous time and discrete time signal. Now we talk about continuous. We have some modeling. So modeling nothing but the signal depends on the one variable. For example, signal is depends on the one variable that is called single dimension variable. One means one dimensional signal. One dimensional signal. For example, x of signal depends on the two variable t1, t2, that is called two-dimensional variable. So one-dimensional example, variable example, one-dimensional example nothing but like voltage, current, and power, and etc. But two-dimensional nothing but like X-ray, image, and so on. So and the signal depends on three variables. Two or more one variable depends on the three-dimensional signals. That is this is also one-dimensional signal. Signal depends on the one dimension. That is the one-dimensional signal. Signal depends on two variables. That is called two-dimensional. Signal depends on three variables. That is called three-dimensional signals. Okay, there is a generally a difference. Basic signals. Various types of two signals. This is a more signal model. So now coming to the basic signals, we have elementary, which is also called elementary signals, and it is also called basic signals. So what are the basic signals we are having? First one is we talk about impulse signal. Impulse signal. So first of all we talk about what definition of impulse signal. The impulse signal is given by the del of t. So in this also we have represented two ways. In continuous time signal also we have two ways. First one is continuous time signal and second one is discrete time signal. This variable nothing but continuous time signal. This variable nothing but discrete variable. There is both of same but represented is different. Now we talk about continuous time signal. The continuous time signal is nothing but the definition of impulse signal. If t is equal to 0, del of t is equal to 1 for t is equal to 0. That means if t is equal to 0, the 1. That is called impulse function. That means how can I represent the graphically? So del of t is amplitude, t is the time variable, and this condition is the impulse function is existing at t is equal to 0. That means that will become 1. It is the impulse continuous time signal. Now coming to discrete time signal, the both of definitely both of but represent is different. Now in discrete time signal, the condition is del of n is equal to 1, t for t equal to 0. That means the signal existing at t is equal to 0, then that will become 1. That is the impulse function. Now we will see. So what is the graphical representation? The graphical representation of impulse signal. So del of n, the origin is 0, 1, 2, 3, 4, and here also minus 1, minus 2, minus 3. Nothing but minus n is the place. Now we are saying n is equal to 0, that will be existing 1. That is called impulse discrete time signal. Okay. So this is the impulse signal continuous time and discrete time signal. So now we have to next signal, that is called step signal. So in this case also we have to represent two ways. First one is continuous time signal and second one discrete time signal. Continuous time signal and discrete time signal. Now we talk about continuous time signal. So how to define step signal in continuous time signal, how to define discrete time signal in the step signal. First we talk about continuous time signal of step signal. So what is the condition of step signal? Let it be denoted by the u of t equal to 1 for t greater equal to 0. That is called step of continuous time signal. So how can I represent it graphically? Now we take amplitude is u of t and time period is t. So what is the condition? T greater equal to 0, the amplitude become 1. That means the positive only is existing on the positive side, the negative will be 0. Means the signal is existing only right side from 0 to 1, 2, 3. That means the signal is constant amplitude from 0 to infinity. That is called continuous time signal. The step signal always amplitude is become 1. This is called continuous step signal. Similarly, in discrete time signal, let u of n is equal to 1 for n less than equal to 0. So this is a condition of discrete time signal. That means these are same definition. In discrete time signal also, the step function exists on the right side from 0 to some values. This in this step signal also amplitude always in always 1 only. That is the amplitude. So u of n is the y-axis, x is the n is the x-axis. But the representation is different. But it is continuously varies time only. That is a continuous time signal. But here the every arrow depends on the particular instant of time, that is called discrete time signal. So let's take 0 and 1, 2, 3, 4 and so on. But amplitude always 1 only. Okay, this is called step signal. So now coming to next signal, that is a ramp signal. So ramp. So in this case also we have to define the two ways. First one is continuous time signal. Second one is discrete time signal. So first one, so continuous time signal and discrete time. So first of all we talk about the definition. So what definition of ramp signal? So R of t is equal to t for t greater equal to 0. That means the signal is also existing on the right side. So R of t nothing but is like a straight line. Straight line nothing but the signal is existing right side from a linearly growing function. That means now we have to implement the graphically. Let R of t is the y-axis, let t is the x-axis. What is the condition? That t is equal to greater than equal to 0. The R of t become t. That means it is like a straight line from the origin to some certain value. It is called linear function. This shape is called linear. So this shape is the ramp signal continuous time signal. But in this continuous we have no any particular time. This is a continuously varying time only. That is called ramp continuous time signal. Now coming to discrete time signal. So discrete time signal. So both are different same, but the representation is different. Now we denote by the R of n equal to n for n greater than equal to 0. But both are same conditions, continuous in this case, but shape is different. Okay. Now, so what definition of discrete time signal? That is every amplitude depends on the particular instant of. But in discrete time signal also, the ramp is existing only right side from 0 to certain value like linear. Now again I implement the discrete time signal. Now we take 0, n is equal to 0, 1, 2, 3, 4. It is called n-axis n. Now we can apply, now we can substitute the amplitude values. Let n is equal to 0, now let n is equal to 1, let n is equal to 2, let n is equal to 3, let n is equal to 4. Now we can combine this all the values, that is called ramp. This is different. This is a continuous variable, this is a continuous time signal, this is a discrete representation. Because of every amplitude depends on the particular instant of time, that is called discrete time signal. This is a ramp continuous time signal, this is a ramp discrete time signal. So now coming to next signal, parabolic signal. So what is the condition of parabolic? So next one is parabolic signal. So it has two types again. Every signal we have represented two ways. First one is continuous time signal, discrete time signal. So what is the condition of ramp signal? Parabolic. So P of t is equal to t square by 2 for t greater than equal to 0. That means the signal is existing only right side because of we are using t greater than equal to 0. T greater than nothing but is the positive axis. So 0 for t less than 0. That means the negative we have to consider that is called all are 0 values. Okay. This is a condition. This is a mathematical representation. Now we can represent graphically. Okay. Now we have to implement graphically. Let's take y-axis nothing but p of t and y-axis nothing but so x is nothing but t. Now we have to get these t values in the condition we get the parabolic shape. So the parabolic shape is like look like. So this is called parabolic continuous time signal. So how to get this shape? Just you can take a p value 0, 1, 2, 3. We can substitute these values. We get the parabolic values. So parabolic symbol. So that is called parabolic continuous time signal. Okay. Now next coming to discrete. So discrete are the same, but you have to change the variables. Let define discrete time signal. P of n is equal to n square by 2 for n greater than equal to g. So now we can represent discrete parabolic function in the discrete time signal. So how can I get shape? Both of get same definition, but the representation is different. Now we can implement in the graphically. Let's take p of n and I x-axis is n there. So how to get shape? But both of them is a continuous variable, but in discrete we have to use every amplitude depends on the particular instant of time. That is called discrete time signal. So this is called discrete parabolic function. It is called discrete parabolic function. So both are same but very different. This is a continuous, this is the discrete time signal. This is called parabolic. So the output get the shape. Just we take t is equal to 0, 1, 2, 3 and substitute in this condition we get this shape. Similarly, discrete time signal, we require this shape where the substitute n is equal to 0, 1, 2, 3. In this equation, we get parabolic discrete time signal. Okay, so this is the parabolic continuous time signal, parabolic discrete time signal. Now, coming to next signal, sine signal. So, sine signal, in the sine signal also we have to represent two ways. First one is continuous time signal as discrete time signal. First we have to represent continuous sine signal and represent discrete sine signal. So how can we represent continuous time signal? We take one mathematically representation. Let's take x of t is equal to a into sine omega t. So using this condition we get a sine signal. So x of t is a continuous variable, a is the amplitude, sine is sine function, omega nothing but angular frequency, T is nothing but the time variable. Okay. So now by using this equation we get continuous sine signal. So how to get this continuous time signal? Just you have to take T is equal to 0, 1, 2, 3 and so on. This value substitute in the equation you get sine signal. Sine signal. Similarly, discrete time signal x of n is equal to a into sine omega n. So n nothing but a discrete variable. Okay. So now how to get shape discrete time signal? Just you can the shape is nothing but sine discrete time signal. So how to get shape? N is equal to 0, 1, 2. This value substituted in this equation you get the sine discrete time signal.